Good morning, friends. Now again I came by taking the 10th parameter for instrumentation parameter as hysteresis. This hysteresis you have been listening from your class 8th or 9th when you started learning magnetism. Now we will talk about hysteresis in context to instrumentation. What is the hysteresis? What is its significance? Right? How it affects to your accuracy. Nowadays, how in a specification hysteresis comes, and very important things in a flow meter, in a pressure transmitters, in the level transmitters, even switches, how this hysteresis works, we will see. So before going to those complex things, we understand first the simple thing first. What is the definition of hysteresis? Here is the definition of hysteresis. Now we will understand the definition of hysteresis first. It's a simple definition, right? So, hysteresis is a phenomena which depicts different output effects when loading and unloading. Hysteresis in a system arises due to magnetic hysteresis, internal frictions, free plays or looseness in the mechanism of instruments. Okay, and this hysteresis is available in a both kind of transducer, whatever it is a mechanical or it is the electronic. Now we will understand what it means. What is the meaning of loading, what is the meaning of unloading, and then what is the meaning of hysteresis, and the most important thing is different output effect when we are giving the same input, means input is one and two output is coming when loading and unloading. Now here you have to recall our earlier lectures too, because there we told about the ranges. We discussed about the 420 milliamps. If this video become long, we will make it in a part 1 and part 2, don't worry, but we will go in the details of the hysteresis. So when we talk about the 420 milliamps, okay, 4 milliamps and the 20 milliamps, 0 and 100 m³ per hour, or 0 or 10 kg per centimeter square, or minus 4 degrees Celsius to 100 degrees Celsius, whatever may be. So what is the meaning of loading and the unloading? If we talk about a pressure transmitter, range is the 0 to 10 kg per centimeter square, means what? Means 0 means a 4 milliamps and 10 kg per centimeter square means a 20 milliamps. Loading means when we are increasing the pressure, let's say up to 5 kg per centimeter square, right? And then we will go to the down, means 5 to 4, 3, 2 and 1, and we will check what is the difference between the loading and the unloading when it is giving the same input. Here first we see in the verbose, this example, example is also pressure, good. Pressure when increase from 0 to 10 and decrease back. So while increasing at 5 bar, we are getting 5 milliamps, okay, from the multimeter, right? And when decrease from 5, the output will come to 2.3 milliamps. So what is the difference between the loading and unloading? 2.5 minus 2.3 milliamps, and it is equal to 0.2. So we will say hysteresis error is the 0.2. Now we will go to the next slide. Here you can understand in the graphical way. Okay. Here what is the meaning of this graph? Here it is the loading and here it is the unloading. Now we will understand how it is the two output for the one input. Let's see at this point. Okay. See this point. In this point when it is increasing, right, loading, that time the output is coming to this, okay, and when unloading, okay, so same input. See my dear friends, please give attention here, then you will understand. So the same input, while the unloading, the reading is again it is the different reading. Okay, this difference of the reading means two output from one input is called the hysteresis in instrumentation. Okay, hope you understand. If you not understand, we'll go in the depth of that. You don't worry about it. Now we'll see how it looks in a specifications. Here, if you see the specification, in specification it is written, you can see, if you go and see the data sheets, specification sheets of the different instruments, you will find these lines, okay, performance specification, okay. Here, what is written? The accuracy is the most of the time, is combined effect of linearity, hysteresis and repeatability. It should be plus minus 5% or 0.5%, okay, or 1%, whatever the type of instrument you are using. Fine. We will discuss these all things later, but here you can understand about this. Now comes to the instrumentation programming or the configuration. So hysteresis is very good also for few instruments, so that your errors and all you are seeing in the less, because when it is loading or unloading, the difference is, there is a difference, so that there will not be chattering. Oh, you don't understand? Again I will tell you, okay. Now you see the example of a label, and you have a label switch, right? Now label, if it is like this should not chatter. Understand? If you go like this and this, then only my switching action will happen. But it is like this and this, then there should not be any action of on and off. So we will put a hysteresis range, and that range of the waves of this label or change of the label, there should not be any switching effect. Now you see it in the flow meters. In the flow meters, that low cutoff, okay, hello. If you see a flow meter with the configuration, you will get a very important parameter as a low cutoff. Hysteresis name also will come, and hysteresis always is the percentage of Q max and with this range. Fine. Now you see the example of pressure transmitters, pressure switches. There, instead of saying the hysteresis, they can tell you like the window. Okay. So these are the different things about the hysteresis. Now we will see more details of the hysteresis here. Okay. If we see here, the same thing. Now you are saying, okay, it's visible to you all. Okay, I will make it full screen also, no problem. Okay. Here you see, if you see it here like this, okay, I am making it bigger for you so that you can see properly. Okay. Here if you see, this is the loading cycle, and this is the unloading cycle, and it is the one input, and you are seeing these two outputs. Okay. Difference between these two is the hysteresis. Now we'll understand with the practical example how hysteresis affects my accuracy. Now we can see it here in a practical way. Let's take example of a magnetic flow meter. My magnetic flow meter range is 1000 m cube per hour. Okay, this is a m cube per hour, and my accuracy is plus minus 5%. Got it? Then how much the accuracy range is? Plus minus 50 m cube per hour. Okay. Now this is the 50 m cube per hour plus minus. If you make here like this, if 50 this side and 50 this side. If I want a more accurate flow meter, then my hysteresis should be low, 10, 5 is this range. If it is going, then my accuracy is better. But if it is hysteresis at 20 means it is coming here somewhere. Okay, it is coming somewhere here. Then my accuracy band is this and my hysteresis band is this. Then this flow meter may not be better flow meter. So most of the time, if you see the hysteresis and the accuracy, so the manufacturer if it is have a high accuracy, then your hysteresis will be less, and it affect the cost. If you have a lower accuracy, means the higher hysteresis, cost may be low, but if it is some application where you need a very high accuracy, then your hysteresis has to be in this range. I hope I try to explain you hysteresis, what is the definition, what is the meaning of loading, what is the meaning of unloading, what is the meaning of a single output and the two different output during loading and the unloading. It is mentioned in the Q max, the percentage, and hysteresis effect on the accuracy, and I also try to explain how in the accuracy and the manuals and all it is given. Okay, please, if you like it, please subscribe the channel, like the channel and spread it, and you also comment me what you like, what you don't like, and what next you want, so that I can make more videos for you. Thank you very much. Thank you, viewers.